let's see here. Morning, afternoon, evening, midnight, whatever time it is for you. Since a couple of yours don't have a key to it, I'll work them out. Put this thing into the vertex form. Y equals x minus h squared plus k. So I'm going to go through and I'm going to identify my A and my B and my C. And what I'm going to do is I'm going to find the x-coordinate of the vertex, better known as h, the x-coordinate of the vertex, by using opposite b over 2a. So this would be a negative 2 over 1, which is negative 2. All right, easy enough. To find k, the y-coordinate of the vertex, I plug it in. Just plug the thing in. That'll give me, I think, negative 3. No, it can't give me a negative 3. Can it? That just doesn't seem right, because that's the y-intercept too. Opposite b would be negative 2. That's fine. A negative 2 squared is 4. Minus 4, that's 0. Negative 3. Huh, that's amazing. I'm just surprised by that. Like, I really want to check myself on that. So, negative 2 divided by, oh, because I'm an idiot, twice a. First one, I do something stupid. Look at that. First one, do something stupid. That looks so much better. All right, so now I'd have 1 minus 2 minus 3. There we go, negative 4. That makes so much more sense. So the x-coordinate of the vertex is at negative 1, the y-coordinate is at negative 4. So y would be x minus h, taking away a negative 1 would be plus 1 squared, and then minus 4. And a, by the way, is an understood 1. So there's your vertex form. A box with a square base and no top is made from a square piece of cardboard by cutting 6-inch squares from each corner and folding up the sides. The box is to hold 20,886 cubic inches. How big a piece of cardboard is needed? I don't know that we can do this one by hand, but this has been done in here. A box with a square base. So originally these are all x's. And then you cut out 6 here, and you cut out 6 here. So that's minus 12, and x minus 12. Now when we fold the box up, we'd be 6 inches tall. We'd be x minus 12 wide and x minus 12 long, because it's a square base box. I know how to find volume. I think it says, yeah, it talks about volume. Volume is length, width, height. So 20,886 must be equal to 6, the height, times x minus 12 to the second. You can write that x minus 12 if you want. I've only got a few minutes before classes start, so I'm going to cheat, use a calculator. I'm going to divide that 6 out because I can, and I got 3481. 3481 is x minus 12 squared. There's a reason I went with the squaring technique. I had a hunch that would be a perfect square. 59. 59 is x minus 12 squared. Sorry, is x minus 12 because I took the square root of both sides. And if I add 12, I'll get 71. So it's originally 70, sorry, not 71. It's 71 minus 12, which is 59. It's 59 by 59. We found x. Not that. So it's 59 by 59. The baseball team plays in a stadium that holds 4,400,000 spectators. With a ticket price at 12, the average attendance has been 19,000. When the ticket price dropped to 9, the average attendance rose to 22,000. Assuming that attendance is linearly related to ticket price, what price would maximize revenue? So revenue is the quantity sold times the price. All right, that's what revenue is. Quantity sold times the price. We've got some points here. When X is 12, Y is 19,000. And when X is 9, Y is 22,000. And it talks about things being linear related. So I can actually write an equation from this thing. I can write an equation for attendance. All right. Y take away 19,000 is the slope here would be 22,000 minus 19,000. Which, by the way, I don't even want to mess with. 22 minus 19. I am just out of it today. 22 minus 9 is 3. 9 minus 12 is negative 3. Negative 1 times x minus, now I'm using 1912. Sorry, it's been a long morning. Negative x plus 12, I'm going to add 19. Y equals negative x plus 31. Anyways, what good does that do me? This is the number of people sold given, this is the number of tickets sold given price. This is tickets sold given price X. So over here, revenue as a function of X would be the would be the price X times the number of tickets sold, negative X plus 31. So revenue as a function of X is negative X squared plus 31X. And a max or a min happens at opposite B over 2A. So this would be negative 31 over a negative 2 times 1, or 2 times negative 1. Anyways, it's $15.50. You wouldn't have guessed it. But anyways, $15.50 is the max. I don't know about you, but I would rather have fewer people in a stadium than a whole bunch if I'm in the business of making money. Because aren't we all? Write an equation for the polynomial graph below. So let's talk about the multiplicities. These are ones. They happen one time because they are crossing points. This is a pretty easy one. This one has a multiplicity of 2. That factor has to happen twice. Turning points, there are 1, 2, 3, 4 turning points, which means at least x to the 5th. All right. By the way, we have a y-intercept. That might be important. So my function f of x or y of x, whatever I want, if a 0 is negative 4, I have a factor of x plus 4. Don't forget about that letter a. If I have a 0 at negative 3, I have the factor x plus 3. If I have a 0 at 1, I have the factor x minus 1. And this one happens at least twice. So x minus 3 squared. Now I needed that because I needed to be at least a 5th degree. First plus first plus first plus second is 5. Now I have the y-intercept here. That's useful because the ordered pair here is 0, negative 2. And I can plug it in and figure out the a value, which I probably don't have to do. It's probably going to be 1, but we'll find out. So negative 2 must be equal to a times 0 plus 4 times 0 plus 3 times 0 minus 1 times 0 minus 3 squared. Then I crank out the math. All right. That's a 9. 4 times 3 is 12 times negative 1 is negative 12. No, it's not. It's not just a is 1. There's a negative 108 attached to a. So if I divide that out, I should have a 56th. So 1/56 of x plus 4 times x plus 3 times x minus 1 times x minus 3 squared. Rectangle is inscribed with its base on the x-axis and its upper corners on a parabola y equals 1 minus x squared. What are the dimensions of such a rectangle with the greatest possible area? So the parabola 1 minus x squared would cross at 1. And drawn inside this thing is a rectangle. We would go x units to the right, and then we would go up 1 minus x squared. But when you talk about the full rectangle, the full base length is 2x. So the area as a function of x is twice x times 1 minus x squared. Now, what you're going to do with this thing is you're going to maximize it in your TI-84. I'm not even going to distribute the 1 minus x squared. We can't use the vertex opposite b over 2a. We just don't have it at our disposal. And there's a maximum right there. Second trace, 4. It's itty bitty bitty bitty. Enter, enter, enter. The maximum happens when x is 4.225, 0.426. This is actually area, by the way. That's saying where it is at. So twice x is roughly 0.853, no, 852. The height is 1 minus x squared. Which is 0.819. That's how you handle that particular problem. Next up is find the inverse of this rational function. I think you guys will do good with that. So x is negative 5x plus 5 over 4x minus 3. I also need to do something like find the inverse of 4x squared dot dot dot. There's going to be more. I just probably won't have time to do a video on it. That needs to be my y's. We will cross multiply. 4yx minus 3x is negative 5y plus 5. We'll subtract 4yx. Actually, I'm going to move the 5y over here. 4yx plus 5y equals 3x plus 5. I did that to keep the numerator positive. I was thinking a step ahead. And I'll divide out the 4x plus 5. Sorry I was so rushed on this. That really has a lot to do with the mistakes I'm making and how incoherent I seem to sound. Anyways, there's your inverse. Make that f to the negative first of x and be done with it. And that's that little video. If you watched it, could have done a better job. I get an X.